All right, this is section 12-1, tangent lines. All right, so start off with some vocabulary. We're going to cross out the word that does not apply to a circle. All right, so all the following do apply to a circle except for the word equilateral. Okay, so let's cross out the word equilateral. And here we go. All right, now number 2, circle the word for a segment with one endpoint at the center of a circle and the other endpoint on the circle, and that would be a radius. Okay. So a new vocabulary word, the word tangent. So a tangent to a circle is a line, ray, or segment in the plane of a circle that intersects a circle at exactly one point. So it touches the circle at exactly one point. And here's an example of a tangent line. All right, so in the diagram, line AB is tangent to the circle at the point B. We call the point B the point of tangency. Ray BA is a tangent ray. Line segment BA is a tangent segment. So another usage. In a right triangle, the tangent is the ratio of the side opposite an acute angle to the side adjacent to the angle. All right, let's complete each statement with always, sometimes, or never. So a diameter is never a tangent. A tangent and a circle always have exactly one point in common. A radius can always be drawn to the point of tangency. A tangent never passes through the center of a circle. A tangent is sometimes a ray. All right, next page. So theorems 12.1, 12.2, and 12.3. In theorem 12.1, if a line is tangent to a circle, then the line is perpendicular to this radius at the point of tangency. All right, so an example of that would be right here. So here's a tangent to the circle, and here's the radius. It is perpendicular, so that's why we draw the line perpendicular there. Theorem 12-2, if a line in the plane of a circle is perpendicular to its radius at its endpoint on the circle, then the line is tangent to the circle. Theorem 12-3, if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So here's two tangent segments. They share a common endpoint, point B. So AB is congruent to BC. So for number 4, theorem 12.1, if line DF is tangent to O at K, then we know that line DF is perpendicular to line segment OK. Conversely, if we know that line DF is perpendicular to line segment OK, then we know line DF is tangent to circle O. All right, theorem 12-3, if line BO and line BC are tangent to circle O, then we know line segment BA is congruent to line segment BC. All right, problem number 1. So ED is tangent to circle O. What is the value of X? So since we know ED is tangent to circle O, and we know this segment that goes through O is a radius and or a diameter, we know it is perpendicular, so we have a right triangle. Okay, so the circle the word best describes OD. OD is a diameter, or excuse me, a radius, since we're talking about O to D. So what relationship does theorem 12.1 support? We know it's perpendicular. Okay, so then the most accurate description of the triangle is that it's a right triangle. So we can use the triangle sum theorem to solve for X. Okay, so we're going to write 180 degrees equals 38 plus 90 plus X. And now we're going to solve. So 180 equals 38 plus 90 plus X. We're going to simplify. 38 plus 90 is 128. And then we're going to subtract 128 from both sides. We have 52 equals X. So the value of X is 52. And that's the end of that prep problem. Okay, problem number 2. So what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth? Earth's radius is about 4,000 feet. So for number 14, a diagram on the right shows the airplane at point A and the horizon at point H. Use the information in the problem to label the distances. All right, so we know this distance is 2 miles. The airplane's above the Earth 2 miles. We know that the radius is 4,000, and we know all radii are the same. So this is also 4,000. All right, we know OH is perpendicular to AH. Okay, so that means OH squared plus AH squared equals OA squared. So we're going to substitute in the values. 4,000 squared plus AH squared equals 4,002 squared. Substituting and simplifying, we get these numbers. All right. Subtracting, we get AH squared equals 16,004. Taking the square root of that number, and we get approximately 126.5069168. So a person can see about 127 miles to the horizon from an airplane 2 miles above the Earth. Okay. So what is the radius of circle O? So we're going to write an algebraic or numerical expression for each side of the triangle. So one side of the triangle is x. The other side of the triangle is going to be 10. And then the hypotenuse is going to be x plus 6. So the longest side of the triangle is going to be x plus 6. The side opposite the right angle is x plus 6. So let's use the Pythagorean theorem. We have x squared plus 10 squared equals x plus 6 quantity squared. All right, and then just use that to solve for x. So we have x squared plus 10 squared equals x plus 6 quantity squared. So we have x squared plus 100 equals x squared plus 12x plus 36. We're going to subtract x squared from both sides. So we have 100 equals 12x plus 36. Subtract 36 from both sides. So 64 equals 12x. And we're going to divide by 12. So x equals 5 1/3. So the radius of this circle is 5 1/3. All right. And problem number 5. So circles inscribed in polygons. All right, so circle O is inscribed in triangle PQR, which has a perimeter of 88 centimeters. What is the length of QY? So by theorem 12.3, we know PX is congruent to PZ. We know RZ is congruent to RY, and we know QX is congruent to QY. So PX must equal PZ, RZ must equal RY, and QX must equal QY. So the perimeter is PQ plus QR plus RP. So P equals PX plus XQ plus QY plus YR plus RZ plus CP. So we're going to find the values. So we have 88 equals 15 plus QX plus QY plus 17 plus 17 plus 15. So 88 equals 64 plus 2QY. So 24 equals 2QY. So QY equals 12. All right. So a classmate insists the DF is tangent to E. Explain how to show your classmate is wrong. So a tangent to a circle is perpendicular to the radius. If DF is tangent at point E, to circle E at point F, then measure of angle EFD must be 90 degrees. A triangle can have at most one right triangle. So a triangle cannot have two right angles. So the segment is not a tangent. All right, and that's the end of the section.